Hello everyone, my name is Nava Ghavami. I'm a graduate civil structural engineering student doing a research with Dr. Faribor Serhani about assessing the design and strength modification factors for rotary-kiln produced expanded aggregates like expanded shell, expanded clay, and expanded slate. In this presentation, I will compare normal weight and rotary-kiln produced expanded aggregates. The term lightweight concrete is used to refer low-density coarse aggregates such as expanded shell, expanded clay, and expanded slate. It is these materials that make the concrete light in weight due to the low density availability in them. This is the outline of my presentation. First, I will give a quick introduction about both lightweight and normal weight aggregates. Then I will talk about manufacturing process of rotary-kiln produced expanded lightweight aggregates. And then I will provide some significance that I found during my research. Then I will do a comparison between lightweight and normal weight concrete by using an example from ASCI 314. At the end, I will conclude my results and I will be more than happy to answer any questions. The primary use of a structural lightweight concrete is to reduce the dead load of a concrete structure, which then allows the structural designer to reduce the size of columns, footings, and other load-bearing elements. Structural lightweight concrete mixtures can be designed to achieve similar strength as normal weight concrete. The same is true for the mechanical and durability performance requirements. Structural lightweight concrete provides more efficient strength to weight ratio of structural elements. A typical concrete compressive strength specification requires 34 to 41 megapascal or 5,000 to 6,000 psi at 28 days. Structural lightweight concrete usually has an in-place density that ranges from 1400 kg per meter cube to 1800 kg per meter cube or 90 to 115 psf, which is different from the regular or rather normal weight concrete that has an in-place density that ranges from 2200 kg per meter cube to 2400 kg per meter cube or 140 to 150 psf. Typically, a concrete mix is about 10 to 15% cement, 60 to 75% aggregates, and 15 to 20% water. Internal air in many concrete mixes may also keep up to another 5 to 8%. The rotary-kiln in its simplest form is a nearly horizontal refractory-lined cylinder, rotating about its longitudinal axis. The raw material is fed into the upper end, and the heat is applied at the lower end, and the material traveling countercurrent the heat flow. The material is heated about 30 to 60 minutes, depending on the length, diameter, and rotational speed, to a maximum temperature of between 1900 to 2200 Fahrenheit, or 1000 to 1200 Celsius. The heating rate is gradual for 2/3 of the length of the kiln. Then it increases rapidly until the maximum is reached, thus heating the interior of the particles so that gases will be liberated to be trapped by gases-formed matrix. These are some significant facts about lightweight aggregates. Lightweight aggregates has more strength, less weight, less life cycle cost, less transportation footprint, less structural demand, less seismic load, it enhances service life, it is durable, it reduces shrinkage. Also, it has a greater moisture retention and higher thermal resistance compared to normal weight concrete. But the only disadvantage is that it has a slow drying period compared to normal weight concrete. Expanded shale, expanded clay, and expanded slate are the main materials for the production of structural lightweight concrete. The current design code approach does not distinguish between different types of structural lightweight aggregates. These aggregates produce differently and are totally different from each other, but ASCI follows the same guideline for all of them. By research and experiments, we will get a different lambda, which is basically the ratio of F'(T) to F'(C), and then compare it to ASCI lambda. By several studies, simulations, and design work, there will be a report on unit weight of aggregates lambda, and then compare the result to ASCI lambda to determine several issues such as safety, environmental sustainability, and economy. Lightweight characteristics of these aggregates make it more effective than normal weight concrete. Structural lightweight concrete is environmental friendly and can help reduction of the negative effects that concrete manufacturing has on the environment. ASCI 314 has an example for a 9-story structure that is designed based on concrete manual by using the lambda for normal weight aggregates. I use the manual to design the same structure by using the lambda for rotary-kiln produced expanded aggregates to be able to do a comparison between these aggregates and common design code approach. As you can see, the total weight of the lightweight concrete is approximately 20% less than normal weight, which can reduce the dead load of the structure and provide more open space for the architect and structural designer. Also, the result includes an elevation of current strength values and provide recommendations to enhance the reliability of design codes for structural lightweight concrete. In previous slides, I talked about both lightweight and normal weight aggregates. I gave a quick introduction about manufacturing process of rotary-kiln produced expanded lightweight aggregates. I also provided some significant facts, and I did a comparison between normal weight and lightweight concrete by using an example from ASCI 314. I can conclude this presentation by saying that there is a need to add an amendment or a new chapter for current concrete manual to benefit safety, environmental, and economic footprints of the projects. For my thesis, I cited more than 2,500 articles, but these are the articles that I used for this presentation. I mostly use ASCI 314 and ASCI 318, and I used some articles to give some significant facts about both lightweight and normal weight concrete.